All right, guys, welcome to another episode of Robo Papers. Today, we're super happy to have Karl Pertsch and Pranav Atreya, who are authors of this paper called RoboArena, Distributed Real-World Evaluation of Generalist Robot Policies. Thank you so much for making the time, guys. I personally am super excited about the work that you guys are doing, as you know. But maybe as a start, if you guys can, each of you share a little bit about yourself first before we dive into the paper. Yeah, maybe Karl, you can start first.
Yeah, my name is Karl Pertsch. I recently finished a postdoc with Sergey Levin and Chelsea Finn at UC Berkeley and Stanford. I collaborate with many awesome students there, including Pranav. And right now I'm a member of technical staff at Physical Intelligence.
Yeah, I'm Pranav. I'm a second year, almost third year now, PhD student at UC Berkeley in the Rail lab. Yeah, and I work on generally robot learning and reinforcement learning. So yeah, the main, highlight of this paper is that we wanted to develop a way to properly evaluate generalist robot policies. And one thing we sort of thought about as we were during the initiation stage of this project was that evaluating generalist policies, which is a policy that can do any sort of language commanded task, is uniquely challenging in a lot of different ways. I think one of the most important things that we came to realize as we were working on this project is that diversity of evaluations, putting the robot in different environments, different scenes, testing out different language instructions was very important. And that to some degree, makes a lot of sense, right? To really tell whether a robot policy is a good generalist, you kind of need to evaluate it on a lot of different scenes, on a lot of different tasks. But at the same time, existing evaluation approaches didn't readily scale to this type of evaluation criteria. Like most evaluation, the way that they go today is that authors often set up their own evaluation setups for their own tasks that they care about for each paper. And these evaluation setups don't typically last beyond the duration of one paper. And so, yeah, hence we sort of worked on this project to sort of try to come up with a better solution for this.
Yeah, I think even more general in some sense, evaluation has been historically a very hard problem in robotics, right? Even before generalist policies were a thing, where it was always very hard to tell what works and what doesn't, because as Pranav mentioned, everybody kind of does their own thing and then re-implements the baselines and shows how they perform. But there are so many nuances in how to implement the robotic system that it's always a bit hard to really know what works. And, the usual process is that you need to yourself kind of try most of the things to really know what works. And then, as Pranav mentioned, kind of this problem gets harder as you move to generalist policies, where now you don't just have that problem in one environment, but you have it in potentially many environments and with many different kind of tasks that you want to test. And so it's a little bit paradoxical in some sense, but it turns out that with generalist policies, there's also opportunity to make the evaluation problem better, because they don't just work in one very particular kind of environment in which you collect the data, but they actually work in diverse environments. And so it's much easier in some sense to evaluate them holistically with multiple people contributing to the evaluation, which was not possible before. And so maybe it's no surprise that nobody had done this before, because you needed the kind of generalizable policies to enable it. But it opens a few new possibilities for the robotics community to work on benchmarks and evaluations that are a bit more shared than what they were maybe in the past.
Cool. So, how does it actually work? I guess it's a distributed network.
Yeah. Basically, the way that this whole system works is that a user, let's say they've trained a policy, they submit it, and they basically host the policy server somewhere. They send us the IP and ports of this policy, and we basically sort of send this policy along with one other randomly sampled policy from the policy pool to an evaluator. And we have this sort of large network of evaluators distributed across institutions. And whenever the evaluator logs on, they turn on the robot, they're ready to run an eval. They get two policies at random from the policy pool, and they run an A/B eval. So basically, they pick any task that they sort of care about, put the robot in any scene that they like, and just run the two policies back to back and determine how good the policies do, and assign a preference score. And basically, this whole operation runs at scale. So we have evaluators, from multiple different places signing on at whatever time they want, and we at the end get this large aggregation of pairwise policy preferences, and we can use that to actually obtain a ranking over all the policies in the policy pool, which is this part on the right here. And this way, we can basically sort of come up with a leaderboard of policies.
So like LMSys for robots.
That's right. I think there's some challenges, in actually implementing it for robots, but very high level. It is basically a crowdsourced pairwise comparison. And it's quite different from how benchmarks usually work, and especially how they used to work in robotics, right? Where you used to have like very narrowly defined kind of environmental conditions. So when people have tried to do benchmarking in the past on real robots, what they usually did is that they literally, put a list of these are the 5 Amazon links of the objects you need to purchase. And then this is the centimeter accurate position that you need to put it in. And here's your camera angle that you need to like match on the exact degree so that your policy performs the same. And I think one of the key realizations as you move to more general policies is that this is not a scalable system. Like you cannot evaluate across 20 or 50 or 100 different tasks, each time making sure that you exactly match the initial conditions. And so this like crowdsourced pairwise system kind of throws all of that out. Like we don't even try to make the tasks consistent. The only thing that we do enforce is that in this pairwise comparison, basically back to back within a 2-minute time span or something like this, there we want to enforce that things are comparable, because this is the thing we rely on, that this pairwise comparison is actually fair and comparable. But then across different pairwise comparisons, we basically don't enforce anything about consistency. And in that way, it's a much more scalable and robust system for evaluation.
Yeah. Concretely, could you share a little bit about the exact, at least as a start, that the hardware system, this early evaluator, I guess, in the network, what are they using? Like, what is the setup like?
Yeah, I can go to the part of the paper that discusses that. So yeah, so we use the droid setup for this first instantiation of this idea. And the droid setup is great because it's this robot over here. Because, a couple of years ago, I think at this point, there exists this sort of large robot data sets collected with this robot platform, in which, in some sense, many of the design principles behind that project were a little bit shared with the motivation here. And that they wanted to, actually Karl is the lead of this, wanted to sort of collect really data in really diverse settings. I think they took robots to all sorts of places, people's homes, etc. Yeah, and all this to say, we basically have with Droid a very nice large open source data set where people can actually train, arguably for the first time, generalist policies that can, out of the box, do very interesting tasks in brand new environments. And this sort of satisfied the key sort of constraint or the key aspect about this whole RoboArena project, where a user now with such a policy is able to command any task that they care about in any environment. And it's very likely the policy will still do something intelligent. And we can sort of use that, aspect or this sort of capability that generalist policies provide to sort of do away with the limitation that we have to evaluate all policies on the same set of tasks and standardize tasks across time. So I think, this figure here shows a little bit more about the exact system. So just to give a high level overview here, the submission of policies by the users and the evaluation of these said policies by the members of the evaluation network happen completely asynchronously. So like a user or set of users may just submit policies to a pool, and they just have to keep it hosted on some server. And evaluators in the network can basically sign on whenever they want to, whenever they're ready to run evals. And we have some central orchestrating process here that'll just assign pairs of policies to the evaluator to evaluate, aggregate the feedback, and then write out the final ranking of policies.
Yeah.
So
maybe if I can make one more point to what Pranav said initially, I think there's kind of two contributions in this work. One is the eval system, which is agnostic to the platform, right? Like you could run a similar pairwise crowdsourced eval on a humanoid robot, or you can run it on a mobile robot, or you can run it on a dexterous hand if you want to. And so this system and the algorithm we use for ranking and all of that stuff is kind of agnostic to the platform and could be reused or expanded. And then the platform itself and kind of the benchmark that we've created around it is more specific to this particular droid dataset and the particular droid robot that we're using. But we really only started with this robot because it's really the only one that has the dataset, as Pranav mentioned, to support it in open source. But we would totally expect and hope that in the future, as more diverse datasets become available, we could expand this to other robots, other morphologies and such. Like I think it's a general way to evaluate robot policies, and we instantiate it on this particular platform.
Yeah, perhaps I can, go a little bit more into like specific sort of pain points that we sort of were thinking about when we starting this project. So I think there's like a few sort of pain points that are consistent across robot evaluation. Like in the broader machine learning community, evaluation is generally, people know how to do it, and it's, they know how to do it well. And, a lot of like open source or a lot of popular LLM or VLM benchmarks are really great at sort of driving progress in the field and making sure, we can accurately assess capabilities of new models. In robotics, I think it's always been a little bit harder simply because A, it's sort of like evaluations require real robot time. And B, it's very hard, again, I think as we discussed earlier, to sort of replicate conditions. And then the main sort of, if I were to summarize in one sentence, the idea of this project is that we sort of embrace the non-stationarity of the real world rather than try to fix everything and standardize everything.
Can I ask, like, how strict is this requirement? I mean, you're starting with this whole droid setup with the Franker arms and all that. So I guess how strict do each of these evaluators have to be in their own so-called droid setup? I guess they are all starting with the same Franker arms. Can it, for
That's right.
example,
So,
be...
I think there are some limitations in the generalizability of learned robot policies that we have today that are real. In Droid, these limitations are a little bit nicer than what happened before. So my experience, for example, working with the Bridge dataset, which is another rather large and popular dataset, is that basically in Bridge, most of the data was collected in one of a handful of viewpoints. And so whenever you want to do an evaluation on Bridge, you spend a lot of time essentially tweaking camera angles to exactly match one of those viewpoints, and the policies don't typically generalize outside of them. In Droid, the diversity of viewpoints is much larger, and so you don't have that problem. People can basically just point the camera roughly at the scene and the policy will be able to deal with it. There's other things in Droid where we don't have variation. Like this is basically just a bias in how the data was collected. To give you an example, the wrist camera angle is very rigid. Basically, there's a 3D printed wrist camera mount and it's always the same. And so if you, for example, were to use a different wrist camera or you were to position it slightly differently, I would expect that to deteriorate policy performance a lot. Or like, people ask, oh, can I take those Z cameras that you used in data collection and replace them with, real sense cameras? And the answer is probably no, right? Because all the data was collected on Z cameras. So you cannot just switch out the camera because all the parameters would be different. So I think the way to think of the Droid setup is it is a certain robot with a certain type of gripper and certain types of cameras, because all of those things were completely fixed throughout data collection. But then there are certain factors of variation like camera angle, table height, environment, task that we did vary intentionally during data collection. And so for those, you don't need to be careful. For those, we actually want you to randomize it as much as possible as an evaluator.
Actually, Karl, one point I wanted to add, that we have a new result in which someone actually changed the Z camera to something else, and the policies do work a little bit decently out of the box, which I think is cool.
Dang, generalization. All right.
But I suppose it's still, in a way, it's still maybe somewhat okay because it's pairwise with the same environment. So you're comparing policy of the same, even if let's say the camera angle is or I mean, maybe the wrist camera is a slightly different one, but at least the policy A and policy B are at disadvantage the same way in theory. So
yeah, I think
hopefully
that's
the
actually
ELO
a good
score
point.
will hold up.
That's right. Technically, this is true. I guess the bad scenario here is if you make a variation that makes essentially all policies fail, then the information that your evaluation provides is pretty minimal. So I think there's a little bit of, hand-holding that also Pranav, for example, did a lot during our project where we just like monitor the evals and make sure that a certain evaluator doesn't just submit flat 0 evals all the way. So, there's like a little bit of, not very sciencey, but just manual engineering that needs to happen to make sure that the eval doesn't deteriorate in some obscure way. But generally, you're right that certain variations, if applied to both policies, should not be a problem.
Did you have to do anything to account for like someone being really bad at resetting the scene, or do you just kind of hope that comes out in the numbers, that you do enough trials that it doesn't matter?
Yeah, I think a bit of both. I think the script that sort of people run when they try to evaluate policies sort of walks them through, making sure that the scene is reset and giving them like what the image looked like before, etc. And I think to some degree there will be a little bit of noise, but I think we found that across a large number of evaluations, the noise sort of gets integrated out.
Yeah, and to be fair, I think we haven't like fully hit the fully distributed setup where we don't actually know the people who are running eval at all. Right, like right now during the project, we ran with 7 labs, and all of those labs we know the people. Now after we released it, a few more people started joining, but even there we kind of have an onboarding process. Michael knows a little bit about it, where we kind of try to make sure the evals are sane, and then we start adding them to the actual benchmark. I think if you were to actually fully open it and just say like anybody with a robot can log on and submit an eval, then I think you would need to put in some more safeguards to ensure that the system doesn't get overwhelmed by bad evals. But I think in the current scale of things, we can still manage it with a little bit of manual handholding.
Yeah, I mean, maybe this is a good point since you're showing this, to talk through like the actual user experience from the point of the guy who's running the eval, like who is writing the instruction, like this feedback presumably is from this guy Eli, and who decide the partial success 25-50%. If you guys can talk through the process like concretely, what does it look like?
Yeah, sure. So basically, the way it works is that the evaluator picks some task, in this case, stacking the bowls, and she runs both policies and sort of assigns partial feedback roughly on like, how much of the task was completed. And this partial success score is like, it's not really a requirement that it's super accurate. And I think overall, what we observed is that these partial success scores are unbiased with respect to like each individual evaluator. But yeah, I think what matters actually is this preference score. And they can, towards assigning this preference score, look at a lot of different things. They can look at task success, and that's usually the metric that people use. But if, for example, two tasks, or the two policies perform roughly equally well, they might look at, just more general vibes. Did one policy complete the task quicker? Was it more smoother? Was it safer? And in some sense, like this simple preference score is kind of powerful because it can sort of encapsulate a lot of different evaluation metrics, like beyond success rate, that somebody might look or care about when running evaluations. Yeah.
This is a little bit a new thing for robot policies. Well, not really a new thing, but like thing that people haven't looked into so much. Like usually in robotics, we mostly care about just like raw success rate. Did it finish the task or not? Whereas in LLM land, I think people are much more accustomed to also caring about style and about being safe and things like this. I think in at least standard robot evals or many of the projects that I've worked on in the past, this wasn't like a center point that we reported metrics on, for example. But with this kind of pairwise evaluation, you can fold all of these into a global score. There's other things, right? Like how fast is your policy? Like some policies may be very good, but they take like 5 minutes to think before they take the next action step. Then, maybe people would be a bit annoyed and maybe they would not prefer the policy, even if it ended up solving the task better. So it's a very kind of aggregate metric that gives you some idea of all these different factors that people may care about. I think there's also like a bit, like there's actually a lot of nuance in how you set up a system like this. Mm-hmm. Like how do you tell people to choose tasks, for example? And I think we try to be very hands-off here, where we tell them kind of anything that makes sense. But then I think over time, and this is a human robot interaction issue, basically, people figure out what the policies typically can do. They will not ask the policy to cook them an omelet because they assume it can do it. But also they will not ask the policy to just like flail its arm in the air because that's also kind of a boring task. And most policies may be able to do it. And so very naturally kind of people find that point. We kind of prompt them basically. We say, try to find tasks where the policy have differing performance. And so they naturally try to find tasks where they're at the frontier of what these policies are able to do. And then you can imagine that over time, as policies get better, that frontier moves. And because our kind of eval system is quite flexible, the eval benchmark can move with that frontier, right? Mm-hmm. Like in the past, if you had a benchmark that did pick and place on 1 million different objects, that was maybe a good benchmark. Then, a year later, maybe people have figured out, okay, I will not claim that we have figured out how to do pick and place in general, but you see the idea, like benchmarks saturate. But if you have a benchmark where people pick tasks flexibly, it's much harder to saturate that kind of benchmark.
Yeah, how do you think about
regarding
sorry.
Regarding the progress score, Pranav mentioned it's a very approximate metric, and I think people haven't done it so much in the past, so maybe it's worth explaining. So basically, the way the progress score is defined, that it's a continuous value between 0 and 100 of how much of the task has the policy solved. So if the task is, I don't know, in this case, I guess, what is it? Grab the phone and press a button. So, if the robot moved its arm towards the phone, maybe that's 10%. If it actually touched the phone, maybe that's 20 or 30, and then if it picked up, it's 50. So it's basically a continuous signal towards full completion of the task. And it's obviously very subjective, right? Like I already was not sure, is it 10 or 20%? We don't really know. But as long as the evaluator kind of applies the same rubric in their mind to both policies, I think this progress score can give a more weighted understanding of the difference in performance. We can say policy B was better, but was it better by a lot or better by a little? I think the progress score can give you a little bit of an idea there.
Yeah,
and it's hopefully more useful than a binary metric, because in many of these tasks, no policy will fully solve any of the tasks, but they can usually make more or less reasonable progress. And so this metric is actually quite informative.
Yeah, I was going to ask, like, how do you guys think about the variability just because you have this human in the loop? And every human, you can instruct them the same way, but they receive instruction differently. Maybe day to day, they do things slightly differently. How do you think about that variability? Is this something that you just diversify away once you have more people? There's just a mean of average
human in the loop. That's a feature. That's not a bug.
That's a feature. Okay. Yeah, talk about it. Yeah. How is this a feature, not a bug?
Yeah, I think actually this video shows a great example of this. Like, this task, grab the phone, press a button. I think it's sort of history aware. Like the robot needs to sort of understand, has already grabbed the phone, etc. And like based off of looking at a lot of these evals over the course of the project, like what I've sort of come to really like is that when you sort of start asking a lot of different people to run evals and give them the permission to basically decide any task they want, you get like a lot of diversity. And I was actually like very pleasantly surprised by like the amount of interesting tasks people are trying out. And I think it's really cool. And arguably, you can only get such diversity or such interesting tasks being commanded, like if you sort of scale out a system to a large number of people. So yeah, I guess to answer your question, yeah, I would say like the fact that, people don't have to standardize tasks and can basically pick anything they want to do, I think in the long run will be like a strength of the system. With respect to building the system and getting accurate rankings, one thing we have to think about when we set this up is that we need to make sure the ranking algorithm can actually handle a large amount of diversity. And basically, every sort of pairwise comparison gives some signal about, in this case, policy B was better than policy A. And the signal is useful for learning the overall ranking. But the task itself, as you can see here, has a lot of variability. It's like one thing that we sort of learned and experimented with in this project was coming up with a way to develop a ranking algorithm that can actually handle the variability in tasks and be robust to very diverse task distributions. Perhaps I can talk a little bit about that. So what we did for that part of the project is we built off of the standard bilaterary model for learning from preference data, which, very simply sort of assigns each policy, in this case, some sort of log ability score that we tried to learn over the course of the inference of this algorithm, which sort of estimates how much better is policy A than policy B. The larger the value of this, the greater the probability that this model predicts that policy A would win. And this model is, used in the LMS's chatbot arena, it's used in a lot of things. But I think one thing that we found was that because the task itself can change, one assumption of the bilaterary model that's being violated here is the assumption that the underlying sort of setup upon which this comparison occurs is sort of static across comparisons. And it's actually not sort of satisfied here. I think like one example is if somebody trains a policy to be particularly good at one type of task, let's say peeling a banana, and the policy is extremely good at that, but it's not a generalist on anything else, then if somebody evaluates on a peeling banana task, it's very clear that this policy that's been specialized will do really well. So it'll beat all other policies on that specific task. But in aggregate, it's only a specialized policy. So basically, we basically just added a bunch of parameters to the model to basically account for this variability in tasks. And when we reran bilaterary with this, we found we got better rankings.
So sorry, when you say better ranking, it means it takes out some of these potential outliers because of very task-specific extremes.
Yeah, so better ranking with respect to what we computed in this project as a sort of global ground truth ranking. So this sort of shows it here. I think that we needed, a way in this project to sort of, towards validating the system, compute how well the final ranking that we get by running this RoboArena system, how well it correlates with that an actual sort of ground truth sort of metric. And the way we sort of set up this ground truth metric is we basically brute forced what running a traditional robot evaluation might look like. In a traditional robot evaluation, we decide on some set of tasks and run all policies on all tasks. So we basically did exactly this. For every single evaluation that somebody did, we ran all policies and computed like this actually global ranking right here. And then we computed, some standard correlation metrics like Pearson and MMRV with respect to this global ranking. And we found that, we can get pretty decent rankings.
But also to emphasize why we can't just run the Oracle all the time is that it gets very tedious. Right, like basically in our experiments here, we had 7 policies in the pool, which meant that every evaluator had to run all 7 of them on every task that they came up with, which was not a lot of fun, I think. It's a lot of rollouts. But you can imagine that as the policy pool grows and as more people submit policies to it, this would get very much out of hand very quickly. And so this pairwise comparison is much preferable over that. And we do find that the rankings after some time, I think we have a convergence curve somewhere. But if you run enough evals in this pairwise setting, you can converge to a pretty good approximation of the exhaustive evaluation pretty well.
Yeah, I have a question. So, it's great that this real world evaluation, looks like there's a way to scale it and really take advantage of the fact that we have now very generalizable policies. How do you think, let's say I'm one of the guys, one of the lab that built one of these models, I'm ranked number 5. What can I learn from it so that I can improve my model? What do you think could be the feedback loop to the model designer, like people building models?
Great question. As if we had planned it. So we basically have this aggregate score, but we try to actually exactly look into this a little bit more because, I think one experience that you gain a lot when you do robot experiments is that looking at just a number at the end is not really telling the full story. And often it helps to actually get a feeling for, what task can the policy do well, where does it usually do worse than other policies and so on. And as a robotics grad student, for example, you get that experience by just running the policy yourself, right? Like you just run it, you compare it on a bunch of tasks, you get an intuition. Now, if you run in this kind of distributed setup, that is much harder, right? Because you're not actually running the policy yourself. Most of your evals are actually run by other people now. And so one way to get that intuition is to look at all the videos, essentially just go through that viewer that Pranav showed earlier and just scroll through and look at all the different rollouts of your policy. It may still be feasible right now, it's roughly, 500 I think pairwise comparisons or something like this. But you can imagine as the system kind of grows, the number of these evals will also grow a lot. And so one thing that we experimented with on this leaderboard page here is that we actually tried to kind of automate to some extent the process of getting an intuition. And this is part of the project that Tony Lee worked on, who can't be here today, but he spearheaded this effort, where essentially we took the pairwise comparisons that we got from all of our different evaluations. And maybe as you noticed earlier, there was a little bit of a language thing there. Maybe Pranav, you can actually go back 1 second to the viewer. So basically the other thing that we haven't yet discussed that we ask our evaluators to provide is this language feedback. You can see it here, where basically the evaluator provides their preference and then they explain why they liked one policy over the other in natural language. And this is essentially there so that we can get a little bit of an understanding, okay, where does this preference come from? Was it based on task success? Was it based on speed, reliability? And it's actually a very rich signal, right? Like it provides a lot of insight into what the policy did well and what it failed on. And we asked them to always specify which of the policies they're talking about. So policy A or policy B. All right. And so we get that for all of our evals. And then what Tony did is that essentially he put all of that into context of some large language model. I think he used GPT here. And he essentially asked it with some clever prompt engineering to summarize and tease out all the different strengths and weaknesses that showed up for this particular policy over all of the rollouts that it was involved in and all of the comparisons. And then we have these nice little reports that Tony generated, which summarize at the top the key highlights of different strengths and weaknesses. And then I think really cool, if you scroll a little bit down, there's more detail and it has citations. I think this is really cool, where essentially the LLM knows which of the rollouts it may refer to when it speaks about a particular strength or weakness. And then we have this cool little feature where you actually see the videos from those rollouts. And so you can kind of verify for yourself whether whatever the LLM summarized is actually, reasonable. And so we don't want to claim that this is perfect, right? Like it's well possible that the LLM over-exaggerates one strength over another, but I think it's kind of a step towards building that kind of intuition and then taking feedback from the benchmark back to model development and trying to make it better. And so we generate these like somewhat periodically for the different policies that are part of the arena as they get more and more evaluations. And then I think this is kind of a nice summary of the current state of where these generalist policies are. And it gives you a bit of an intuition what are the things that they certainly cannot do at the moment. Yeah, so if you look through these, I think there's a lot of things that we can improve about how these policies perform and what they struggle with. And I think this is the kind of stuff that people could take back. Maybe one additional point to your question, I think it also points to something that is a bit of a limitation of this approach, if we want to talk about limitations. One thing that it is not very good at is very scientific ablation, right? Like one of the very powerful processes in science is that you take a system and you take out individual pieces and you just test, okay, what happens if I take out this piece to the performance of the system? And that can give you a very kind of sharp intuition on, okay, this particular piece of the system contributes to performance in this particular way. And this benchmark is not really designed for that, right? Because it's not designed for somebody to submit 50 different policies all with a little bit of ablation on them. It's really more designed to kind of measure the holistic performance of a good policy across a very diverse set of tasks and diverse set of initial conditions. But it's a little bit harder to pin very precisely for many different ablations what are the individual contributions. And so there, I think this is not the only benchmark that we should be using. We should have more controlled setups, ideally in simulation where evaluation is cheap. I think people are working on these tools too. So, I think there are strengths and weaknesses of different benchmarks. I think the strength of this one is that it really tests very holistically on many different scenes and tasks. I don't think its strength is that it provides you a very precise comparison under very controlled conditions with just one change.
Yeah, but I think it is a big trade-off. It is a great trade-off in that you have something actually at least verifiable by a bunch of other people in the network instead of you're self-reporting a baseline that is hard for someone else to verify.
That's right. I think we haven't actually stressed this point too much, but I think this is very important. The evaluators who run the evaluation do not know what they're evaluating. Right? They could be evaluating their own policy. They could be evaluating somebody else's policy. They don't know. Me submitting a policy, I don't know who will be evaluating my policy or on what tasks. So it is a very trustworthy system in some sense. It's very hard to game, right? Like I submit a policy, you evaluate it. You don't know that you're evaluating my policy. And so it's all very kind of double blind and fair. And I think that's one of the strengths here, that I think if somebody performs really well on this benchmark, I would be quite convinced that their policy actually works because it's very hard to game this benchmark, I think.
But you are evaluating over the internet, so you still get do you do anything to account for the latency?
Okay, that's a great question. So this is a bit of a trade-off, right? So I think Pranav mentioned this earlier, that we're running these policies on servers remotely. And so there is some latency aspect to it, right? Because you may have your server somewhere in Europe, or you have it somewhere in Asia, and then you get evaluated somewhere in the US. So there will be some latency added. In the grand scheme of things and what we have tried in our experiments, I don't think it's a major factor. Basically, the droid tasks aren't very dynamic, so they don't really require real-time control. A lot of the models that we have tested aren't that fast out of the box either, and so the latency isn't terrible. The reason that remote hosting is really great is because A, you kind of put the burden of hosting the policy correctly on the author of the policy, which is usually the most qualified person to make sure it gets hosted correctly. B, you put the burden of providing compute for that policy onto the author of the policy. So if, Google trains their Gemini robotics on 1 million TPUs, then they need to provide 1 million TPUs to run it, and not, somebody who is volunteering to evaluate it. And then the third, maybe somewhat minor point is that people don't need to share their policies and their weights with anyone. In academia, I don't think this is a concern, but if we wanted to, for example, have industry folks also participate in this benchmark, which I think would be great, then it's maybe easier for them to participate if they don't need to actually send their weights around the world to people to evaluate. But then maybe the flip side of this point is that if we wanted to eventually do more dynamic tasks, which I'm sure people are interested in, we may need to find ways to at least partially run policies more on system so that the latency is not a concern. But that's a technical challenge that we didn't want to touch, so we left it out for this project.
Yeah, this is like the blind, Pepsi Coke test, blind test, and I was wondering, like, this is not a technical question, I guess, but how do we incentivize more, like the Pepsi and the Coke producers of the world, right? These model creators to put that model to the test.
Yeah. Is Gemini robotics on this yet, or no? I guess that's
I'm trying, believe me.
Yeah, I think regarding incentives, I think out of the box, there are a couple of things that are nice with respect to the system. I think one, the system is set up that you don't actually need a robot in order to evaluate your own policies, basically. You just need to train a policy and submit it. And so people without, access to the resources like the robot platform can actually get the robot policy evaluated. So hopefully, for a lot of people that does incentivize the use of the platform. I think perhaps, the more salient aspect here is that I think with such a sort of shared and community-run evaluation platform, what it enables is people to get really good comparisons between their approach and other approaches. I think in current or before this project, it was always difficult to sort of run baselines. Like I have to now, set up the baseline, try to replicate an environment that's approximately looks like what the baseline was trained on and is supposed to do well on in order to evaluate against it. But I think with this, like with, first of all, the shared problem statement of developing generalist policies, which I think is, a problem statement that most roboticists want to or are pursuing. Something like this enables really easy comparisons between methods, and it can allow for, as a result, really good sort of science and the rapid improvement of policies. So I think if people want to actually see whether their method is better than other methods in the field, this is a really good way of getting those types of comparison results for them.
Yeah, I think the question, how do you get people to participate in your benchmark, is always a question when you make a benchmark, right? I think here, as Pranav mentioned, I think there are some incentives that are really well placed in the sense that people want to evaluate their policy in many environments, but actually doing it just by yourself is really, really hard, right? Like if you had a droid set up, even if you had one, just, carrying your robot to 50 different scenes is a really hard task. Whereas sending your robot policy to a server and then having it evaluated by 50 other people in their one environment is a much easier task. So there is incentive in that way. I think the other way in which benchmarks become more adopted is just by, group effects, essentially. If enough people evaluate on it, eventually people will ask, well, why didn't you evaluate on that? Yeah. So I think, there's a certain activation energy needed. I hope that it will catch on. I think it's worth trying, but I do think it provides some unique things that are very hard to get, even if you wanted to do it by yourself.
Yeah, I think that if you allow, I don't know whether you already allow this, anonymous, like, model contributors, like company anonymous, or maybe like they give a contribution to the project, and then in exchange, like, just tell me my ELO score, but don't publish it at all, like either of those. And so they get what they want, but they contribute to the project, but in a way that is not public. I think
it's a bit of a fine line, right? Like we have seen where this led for LLM evaluations, where it's not great if you advantage some players. And I think for now, all of our evals are very much public. So if you submit a model, maybe not your name, right? Like we can totally have people anonymize the names, but at least the rollouts are supposed to be public, also as a way to build trust, right? Like we don't want people to think that we're cherry picking evals here. All the rollouts are public, all the results are public, and so anybody can double check that one policy actually does reasonable things when it's high on the leaderboard.
Yeah. I'm curious, like, you have, let's say, I'm sure you start out with 5 or 6 policies, but let's say, this project starts to scale, you have like hundreds of policies. And obviously the newer ones, like, I guess I'm talking about the prioritization of like how to make sure the newer policies get enough evals, but then, still have enough evals with the older ones. Like, how do you guys think about that as more eval models come online?
Yeah, actually, towards the end, we have an algorithm in place that'll basically upsample newly submitted policies based off of how many times they've been evaluated, and how recent they are. So yeah, that's in place, and we actually tested out doing something like that. I think we had from the initial sort of paper writing stage of the project, we ran the whole RoboArena trial run on like a base set of policies, but then we added a new policy afterwards, and we saw that it would sort of get prioritized evals, and we quickly actually converged to what the true ranking for that policy was. And I think in a more broader long-term sense, I think it's very likely that as policies get better and better, the set of tasks people will care about evaluating will also change, I think, as discussed a little bit earlier. And I think one thing that we actually tested in actually the rebuttal phase of our paper submission was what happens if we increase the difficulty of the tasks, but phase out weaker policies and bring in more capable policies. Like, do the rankings still hold? And we did find that they do. And we actually hope our system will be used that way, that as policies get better, people will submit them and we'll see them being able to do more challenging tasks.
But do you think adding in more robot modality platforms will change rankings, though? Do you have to like filter or sort or weight by them?
Yeah, it will be an interesting question. I think, there will be, with robot platforms, it's a bit tricky. Like, I'm thinking basically, how does LMSys do this, right? Like, LMSys has different leaderboards for different aspects that people may care about, like, the math leaderboard and the coding leaderboard and whatnot. Their benefit is that every language model, by definition, can be tested on every leaderboard. All right, because they're all just language tasks. I don't think for the current design of robot models, this is quite true, where like if you take, your Pi0 model and you try to run it on a humanoid, it will not be a very pleasant time because it will probably destroy your humanoid in some way. So I think initially, if we were to add more robot platforms, you would probably need to have some way for people that submit policies to indicate which of the platforms they think their policy should be evaluated on. And then probably we would need to have leaderboards for like cross-embodiment policies that evaluated on all the platforms, and then maybe specialist policies that only evaluated on Droid or something like this, or only evaluated on the drones. All right, like I'm projecting. It's not like we have drones lined up, but so I think there would just need to be a more granular leaderboard structure where you don't just have the one leaderboard for everything, but you would have somewhat specialized models and you would provide leaderboards for them.
Well,
you don't
I was
want
thinking, Sorry, well, I was thinking more like just like the Tross and Aloha arms, right? Something like that, which is I think it's a little bit more common these days than the Frank is a very academic arm, right? Like it shows up in like all the top tier academic labs, I would say. Not so much in the, So, but those are very similar. I would expect a model to run on both, but I could definitely see big performance differences between the two, right? Like I could see policies trained on more Trossen data, like doing much worse on your Franka Droid data set, for example.
Definitely. Yeah, I think so. There, it would probably just be helpful to break out the leaderboards into different ones or have more information in your final ranking. Yeah, I think what is blocking there right now is just not enough data available. Basically, like right now, we don't have a data set for Trossen or Aloha where you can just train and it will generalize to a new scene. But so, for example, like to give another example besides Droid, where this is true, I think the AGI-bot folks put out this Colosseum, or I forgot what it's called, or AGI-bot World, I think.
Yeah, 1 million
like,
hours or something like that, like, or 1 million episodes. Yeah, so something
it sounded like a lot.
Yeah.
I'm not sure whether it's easy for academics right now to purchase the platform that they have collected this data on, but I would expect that like in the next 1 or 2 years, basically every major hardware provider will have a large incentive to have also a nice data set that people can work with to make their hardware useful. And so as that happens, I think we could increase the number of platforms that we support, and then we could also have different leaderboards for those. I think there is a bit of a trade-off, right? Like for an academic benchmark, I think you don't want to overshoot the complexity also, right? Like you don't want to force everybody who wants to participate in the benchmark to build a model that aces all the robot platforms and is trained on a gazillion hours of robot data, right? Because kind of at some point, there's no point, right? Like we're not trying to build the best possible robot policy. We're trying to do science on how to make better ones. And so kind of the complexity of your benchmark should encapsulate all the key aspects that you care about. Like maybe you want to have diverse data and should be human collected, so it's not too little diversity in actions and it has multimodality and so on. But then, and so cross-embodiment is certainly one of those factors that people seem to care about, right? And so having some cross-embodiment in the benchmark makes a lot of sense. But I think then eventually, like forcing everybody to be able to control every robot in the world, I think is maybe a bit of a tall order for an academic benchmark. And so there's probably some trade-off. Yeah. And I do think that the droid dataset actually provides a lot of interesting variability that people would generally care about in a larger robot dataset. Yeah. Maybe one point I also want to make here, I think when people think about generalist policies, they have the preconception that it's kind of a thing that only industry does or that only industry can do, right? Because it's like, oh, you need like a compute cluster and you need to have like resources that nobody in academia has. And I want to kind of refute that a little bit. I think with the droid dataset and this benchmark, we are very much in the realm of things that academia can train. So alongside the release of this dataset, we actually released code to train the baseline policy, essentially a reasonably state-of-the-art VLA model in the OpenPy codebase based on the Pi0 model, fine-tuned on the droid dataset. And so this model you can train on a 8H100 node within 2 days. And so if you put that into a dollar amount, that's like less than $100 of actual compute cost if you were to rent that server from a provider. And so, this is not nothing. And I don't want to claim this is the same as training like a model on Mujoko, but it's also not unachievable. It's very much within the realm of what, academic labs can afford to do. And so I think it's really exciting in the sense that people can do research on these quite capable systems that can actually now be deployed in many people's labs on a budget that is very much feasible for academia. So I think like one takeaway hopefully from this podcast today is that generalist policies are very much a topic that academia can actively contribute to. And I think we have a lot of the pieces in place to make that quite feasible.
What would you say is something you would love to see? I mean, I imagine it sounds like this is just a first step of maybe a much bigger thing. What would be a great outcome like for RoboArena, let's say in a year's time? Like what would you love to see in terms of, I think, people contributing or
Yeah, for me, I would say the best thing I'd hope to see is the benchmark actually being useful for people. People are finding that they can train policies and they can sort of use the platform to conduct science and how to train better generalist policies. I think that'd be a great outcome.
Yeah, I think if people kind of develop the habits to report RoboArena results in their generalist policy papers, like I think we see a lot of VLA papers these days, right? Or like more generally, generalist policy papers that all want to do some large pre-training and then fine-tuning and like all of this stuff. And I usually find it quite challenging to know what works and what doesn't. And so if in a year's time, most of these papers did all the experiments they do today, but they also submit a droid policy to the RoboArena benchmark, and then put the number somewhere in the paper, I think that would be extremely helpful. And I would consider that a success. Also, if many people just participate as evaluators, I think that would be great. I think that builds trust and that builds shared kind of effort on what we're trying to push towards. And so I think that would be really great outcome.
And actually towards that point, we're actually already kind of seeing that. I think we are at the point where we're seeing like almost every day actually new evals run. I think, Michael, you're helping a lot with that as well. So I think it's pretty cool that people are interested in sort of helping the benchmark run and sort of remain a resource for the robotics community. I think it'd be really cool if people could use that.
Yeah, maybe we can plug our Karl challenge here. So at this year's Karl, we're actually organizing a challenge around this benchmark. The timeline is fairly short now, but I think people can very much still participate. Yeah, and basically all the resources are on the website. We essentially provide a budget of free evaluations for anybody who wants to participate, and you can just try it. If this is your first time training a generalist policy, I feel this is a great way to get started. Just train a policy, submit it, see how it does. Be a fun competition to be part of, I hope.
Very cool. How long about does it take to get results back? How long do you run it?
Yeah, I mean, the results come back in real time, right? Basically,
Sure,
as soon as somebody finished your policy evaluation, it will show up on the website.
I guess when do I know I can like include it in my paper, I guess? Maybe that's a better question.
Yeah. I think, so the leaderboard recomputes itself every 1 hour, but I think based off of the rules in the paper, it takes almost around up to 100 pairwise evaluations to sort of get that. So probably just like 3 to 4 days in RoboArena would constitute a pretty confident ranking.
Depends on how good your policy is. If it blows everybody else out of the water, you just need 10 evals to know.
That is true.
Yeah. So, I think this is a practical challenge in some sense, right? Like, especially, as people walk up to deadlines and they're like, a day from the deadline and now they need another number for their paper. It will be hard to provide that through an evaluation like this, right? Like no LLM company submits to LMSys the day before their release, right? It needs to have some headroom. But I think on the other hand, you get an evaluation that's very trustworthy and very high quality. So I think that's the trade-off.
Awesome.
Yeah.
Really exciting.
Yeah. I mean, I think this is a really, really great initiative. I think like many people are thinking about collecting data, but I think perhaps real-world evaluation is even a bigger problem, especially for robotics. So I'm really glad that you guys are doing this. Maybe just as a wrap-up, like we would like to ask this question, like, are there any like recent papers, maybe it don't have to be recent, but like any papers that jump at you, like you want to just give a shout out to? It doesn't have to be anything related to like real-world evaluation, anything that you think is cool, you want to give a shout out to. I mean, honestly, we use it as a way for me and Chris to find the next guest, basically. You know, it's also partially why we asked this question.
Yeah, there's one paper that I really liked recently. Let me find the exact title of the paper. I think it's called Grounded. It's not a robotics paper at all, actually. Grounded Reinforcement Learning for Visual Reasoning. I think basically like if you notice, like, I think if you use like what are the latest ChatGPT model, many times if you provide an image that's like really high resolution, it'll actually write code to just crop parts of the image, zoom in, and then call itself on the same image and basically do this iterative visual reasoning. I think this paper sort of replicated a lot of those ideas, and I thought it was really cool.
From CMU. Okay, I'm looking at this. Okay.
Yeah, that's a cool.
I think anything that pushes generalization of VLAs is really cool. It's hard for me to pick one because, again, I have trouble like knowing which of them actually works and which doesn't. But I think, papers that work on using reasoning to improve generalization, or using video model pre-training or human data co-training to improve generalization, I think this is the stuff that I like. I would like to see them evaluated in a way that I know what works, but I think that's really cool. And then I think anything dexterous hands is also really cool. It's a bit longer horizon, right? Like, I don't think we have the really nice dexterous hands today, but I think it seems like a very fascinating problem. Much harder to just learn from the internet from like text, right? Like, you can't learn how to move your hands from text. So it seems like that would require a little bit more, some different way of actually getting large scale transfer to happen. Seems very cool.
Yeah, we should get the more dexterous hands kind of research paper like authors come on.
I mean, like some reality here is that probably we're just like really hardware bottlenecked on the dexterous hand side, and maybe we just need to wait a year until the hardware gets better. But I think it is very exciting to work on this kind of stuff.
Yeah,
for sure.
There'll be some good ones by next year, right? There's those Sharpa hands coming out. That'll be the let's see, something like that. All these open source hands.
Yeah, for sure. All right. Anyway, thank you so much, Karl and Pranav. Like, this is a really great conversation. Like I said, really dig what you guys did here. I think it has the potential to grow, and it's something very unique, right? Like, I don't think we have this kind of almost like crowdsourced way to do real world eval. So very glad you guys did it.
Definitely something that I feel like the field has been missing. The evaluation has always been a huge problem in robotics. So it's great to see stuff like this. I hope the challenge goes well. I hope everyone listening submits a VLA or something.
They should. We have a Discord. We provide support. You're not alone. Just try to submit and we will help.
Yeah, I can vouch for that. Support is great. All right, cool. All right, thank you so much, guys. Okay, cool.
Sounds good.
And
Thanks, guys.
I will. Okay, hold on.